Hello everyone, welcome back to Sulekha Physics classes. It is the most easiest way to learn all the concept of physics through this class. Now today I am going to solve some numericals based on the topics which we already discussed in the previous videos, right? So first I am going to write all the formulas at one side so that it becomes easy to solve the numericals, right? So number one formula which we already discussed, that is average speed. What is the formula for average speed, right? So average speed is equal to total distance traveled, distance by total time taken, right? This is the formula for average speed. Second one is average velocity. Average velocity, and it is equal to displacement. Velocity, then displacement by total time taken, right? Okay, and one more important formula, that is acceleration. Acceleration is what? Change in velocity per unit time. So if initial velocity is u and final velocity is v, so change in velocity is v minus u by total time taken, suppose t. This is the formula for acceleration. Mainly these three formulas are used in the numericals, right? So first I will take examples from the NCERT book, right? So let us start first example number 8.1, page number 101. Page number 101, and this is example number, this one is 8.1, right? Okay. In this question, it is given that an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object, right? So first, the most important thing to solve any numericals is that you have to write all the things which is given in the question. Then after that, what you have to find? Just write that was symbol and question mark. Then which formula you have to use. So I am going to solve step by step. Okay. So in this example, it is given it travels 16 meter in first 4 seconds. So distance is, suppose S1 is 16 meter and time is given 4 seconds, right? Then another 16 meter, it means another 16 meter S2 is given in time, how much? 2 seconds, right? These things are given. Now you have to find average speed of the object. So write down just average speed and then question mark, right? These things are given in the question. Now which formula you use to find the average speed? This is total distance by total time taken. Simply you just add these distances S1 and S2, then total distance, and these two time, then total time. In this way you calculate average speed. So average speed equal to total distance. Total distance is what? S1 plus S2, and total time is what? T1 plus T2. So 16 plus 16 by time is 4 plus 2. So 32 by 4 plus 2 is 6, right? Now then you divide 32 by 6. This becomes 6 5s are 30, then 20, 6 3s are 18, 5.3, again 3 meter per second. This is the value for average speed, right? V average. Okay. In this way you solve this question. Okay. Note down. Then after this I am going to solve example number 8.2, page number 102, right? Okay. Page number 102 and example number 8.2, right? Okay, in this question it is given that the odometer of a car reads 2000 kilometer at the start of a trip and 2400 kilometer at the end of the trip. It means, you know, odometer. Odometer is a device which measures what? Total distance traveled by the vehicle, here car. Okay, so at the starting of the trip the odometer shows 2000 kilometer and at the end of the trip it shows 2400 kilometer. It means how much distance traveled by the car. So you just take difference between these two readings, right? And after that, if the average trip took 8 hours and total time taken by the car to cover these distances 8 hours. Again, you have to calculate average speed of the car in kilometer per hour and meter per second also, right? So first write all the things which is given. So it is given that distance traveled. How much distance traveled by the car? Initial reading is 2000 kilometer and final reading is 2400 kilometer. It means total distance traveled is 2400 minus 2000 kilometer. Okay, and when you take the difference of these two, you get 400 kilometer, right? After this, in how much time? Time is given, total time is given 8 hours. I am not converting this kilometer into meter and this hour into second because you have to calculate average speed in kilometer per hour first. Then after that meter per second. Okay. So what you have to calculate? Average speed. Again, which formula use? Number 1. Total distance traveled by total time taken. Right. So first average speed is total distance traveled is how much? 400 kilometer and total time is how much? 8 hours, right? Okay, when you solve this one you get the answer in kilometer per hour. Okay, so 8 5 are 40 and 50 kilometer per hour. This is the value of average speed in kilometer per hour. Now again you have to convert this in meter per second. How you convert this one in meter per second? Average speed in meter per second. So in 1 kilometer, how much meter is there? 1000 meter, right? And in 1 hour, how many seconds? 60 into 60, that is 3600 second. So when you solve this one, you just cancel this one, right? And this 500 divided by 36. After solving this one, you get the answer 13.9 meter per second, right? This is in meter per second. You also convert this kilometer per hour into meter per second by using this formula. Write down here. 1 kilometer per hour. 1 kilometer means 1000 meter. 1 hour means 3600 second. And when you divide 1000 by 3600, you get 5 by 18 meter per second. Okay, so if you want to convert this 50 kilometer per hour into meter per second, you just multiply by 5 by 18. Then it becomes very easy to calculate very fast and also. Okay, so in this way, this answer is in kilometer per hour and this one is in meter per second, right? Okay, note down. Next, I am going to solve next example 8.3 of the same page number. Okay, example number 8.3, right? Mera bit, I think, hope you have noted. Okay. In this question, it is given that Usha swims in a 90-meter long pool. The length of the pool is 90 meter, right? Okay. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. It means the length of the pool is this one, and she moves from this one side to another side, then again comes back. It means total distance she covered how much? 180 meter. It is given in how much time? 1 minute. Okay. So total distance is given from one end to another, then again come back. This is 180 meter. And total time is also given. Total time is how much? 1 minute, right? These two things are given. Find the average speed and average velocity of Usha. Okay. Average speed, you use this formula, and for average velocity, you have to use second formula. So, what is average speed, right? Average speed. Total distance by total time. And what is total distance? 180 meter. And what is total time? 1 minute. You have to change this minute into second. And 1 minute, 60 seconds, right? So you write 60 seconds. This and this cancel. 6 1, 6 3 is 3 meter per second. This is the value for average speed. Now, second part, you have to calculate average velocity of Usha. Average velocity is what? Displacement by total time. And displacement is what? Distance between initial position and final position. So, initially, she starts from this position and reaches to another end and again come back to the same position. It means initial and final position is same. So, displacement is how much? If initial and final position is same, it is also given that displacement is 0 meter, right? So, average velocity, it becomes how much? Average velocity is displacement by total time, and displacement here is 0. Total time is 60 meter, and this is in second, so it is 0 just, right? 0 meter per second. In this way, you calculate average speed and average velocity problem. Okay. One more last example is given based on this formula acceleration, that is example number 8.4, page number 103. Okay. So now I am going to solve this one. Page number 103, example number 8.4. Right. Made up this one? Okay. In this question, it is given that starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Okay. Initially, it is given that starting from a stationary position, it means initial velocity is what? 0. And when he pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds, right? So, first case you write down. First case, right? There are two cases in this question. It is given that initial velocity is what? Cycle is stationary, initial velocity is, it means u is 0, right? And final velocity, v is how much? 6 meter per second. In how much time? Time is 3 seconds, right? Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. After this, he applies the brake and velocity comes down to how much? 4 meter per second. It means in the second case, initial velocity is what? 6 meter per second, and when he applies the brake, the velocity reduces to 4 meter per second. So this is second case. In this case, initial velocity is this one, 6 meter per second, and final velocity reduces to 4 meter per second. Here velocity decreases after applying the brake. And how much time? Next 5 seconds. Next 5. So time is 5 seconds. Okay. Now calculate the acceleration of the bicycle in both the cases. Now you have to calculate the acceleration in both cases, first and second. You have to use this formula. Acceleration is change in velocity by time. Final velocity minus initial velocity by time. So in first case, you have to calculate acceleration, right? Acceleration. Okay. So this A, this is the symbol for acceleration A. A equal to final velocity minus initial velocity by total time taken. Final velocity is what? In first case, 6. Initial velocity is 0 and time is 3. Okay. So it becomes 6 by 3. It means 2 meter per second square. Okay. This is the value for acceleration in first case, right? In the same way, in the second case, initial velocity is this one. What is the final velocity for this one? 6 meter per second. And then he applies brake. In that case, initial velocity is 6 and final velocity reduces to 4 meter per second. In time, 5 seconds. So acceleration becomes initial is 6, final is 4. And always change in velocity, final minus initial. Whether final velocity is smaller than the initial velocity or larger. It is always final minus initial. So 4 minus 6 by time is 5. This is minus 2 by 5. And it comes in minus sign, negative sign. This is 0.4 meter per second square. This is the acceleration in second case. In this way, you calculate acceleration in the two cases, and you know that this is positive acceleration. It means its final velocity is greater than initial velocity. Its velocity increases with time. And this acceleration is in negative. It means this is the case of retardation, where speed decreases after some time. It means final velocity is less than initial velocity. This is the case of retardation. In this way, you solve all the questions based on these formulas: average speed, average velocity, acceleration, right? I think it's clear to all of you. Okay, note down it fast. Okay, with this I am going to end the class. Hope you have understood all these things. Now in the next video, I will discuss about graphical representation of motion. How motion can be represented with the help of graph, right? In that one, we will discuss position time graph, displacement time graph, speed time graph, velocity time graph. All these things we will discuss in the next class. Okay, students? Up to then, bye-bye. Take care, students.